Hi everyone, I'm Yaşar, and today I'm going to talk about the blind spot warning system. I'm going to talk about the purpose of it and materials used for it, and then I'm going to talk about the working principle and show some schematics about how this project works. So let's start with the purpose of it. We all know that most of the heavy cargo hauling vehicles, aka cargo trucks, have blind spots around them. They have 4 blind spots, one on the front, one on the back, and 2 on the sides. And I think that the 2 on the sides are the most important ones because most of the accidents happen caused by them while the trucks make turns or change lanes. Therefore, I'm going to be focusing on the blind spots on the sides in this project. The purpose of this project is to detect anything going through the sides of the truck and hopefully warn the driver. The materials I used in this project are these, and I'm going to talk about them one by one. First one is an Arduino. This is a necessary part to do the coding part. Ultrasonic sensor. This is used for measuring the distance between the object and the sensor using the ultrasound waves. A buzzer to warn the driver when there's an object. Jumper wires, it's used to connect the components to each other. Breadboard, I used it because I wanted the components connections to be more tidy. Resistors, I used it to limit the amount of current going to the buzzer, especially to prevent it from being damaged. And now I'm going to talk about the working principle. This project works first by ultrasonic sensor scanning the field in front of it for objects. And if there's an object in the field and the distance between the sensor and the object is less than 1 meter, the user is given a warning using the buzzer, which that sounds frequency is specified, and in this project, which is at 1 kilohertz. And when the warning starts being given, it doesn't stop until the object is completely out of the sensor's field. And here is the code of my project. Here you can see that I have specified first the distance between the object and the sensor to 0. And here I use this function to measure the travel time of the ultrasound wave. And then here I use the travel time and multiply it by the speed of ultrasound wave, and I found the distance between the object and the sensor. And if the distance is smaller than 100 centimeters, then I use this code to send the buzzer a signal to make sound. And else, if the object is not in the field anymore, then I set no tone, which means don't make sound. And the sensor keeps scanning every 100 milliseconds. Here's the schematic of this project. The buzzer is connected to 13th pin. Here you can see, you have seen on the code also. And here I use the resistor. And here's a quick representation of how the project can be used. Here you can see the blue areas, which are the sensors fields. Sensors are always scanning this area and detect if something goes in this area. A conclusion, I think the project is more suitable for trucks that are higher from the ground, because when the truck is closer to the ground, the sensor might give some wrong warnings, I think. And I think also that notification of any means should be good for both the driver and the other people's safety. Another thing is that this sensor might not completely stop all the accidents from happening caused by the blind spots, but I believe that it will decrease the chance of them happening significantly. And thank you for listening, and now I'm going to briefly show you the simulation of this project. Thank you. Hi again everyone, and now I'm going to briefly show you the simulation of this project. And here is the circuit, and here is the code, as you can see, and here is the monitor where you can observe what the ultrasound and Arduino calculates in real time. So let's start the simulation. And you can see at first that the object is 300 centimeters away from the sensor. And let's say it's a pedestrian or a car. And let's start taking it closer to the sensor, like this. And as you see, under 100 centimeters, it gives a warning, which is very loud. And when the object is out of that distance, it stops giving the warning. So thank you for listening.